So this is really just a uh, quick video to remind me of what I'm doing and how I'm doing it, but I'll share it anyway. This is a Python-based time series prediction video where the pycaret package is being used. So let's jump over to the dual screen and take a look at what we're talking about. So we have a pretty simple situation here where in the Jupyter notebook, I have a couple things I'm trying to do. Um, I use the pycaret package to look at all of the models that are available in pycaret and then pick one of them out and do a prediction of future temperatures at San Francisco Airport. So let's take a look at the Python package workbook. So we import pandas. We've got two data sets. We've got the training data set and test data set. They're just CSV files, are only for one airport, which is this monitoring station here. We'll look briefly at what's included in these two packages, but they're simple. Here's the training data. Starts on January 1st, 1980, goes through July 25th, 2021. So that's 41 years of data. You can see we have a precip column, Tmax, Tmin, and Trange. Now, in this work that we're going to look at today, this is going to be a single predictor. We're only going to use historical Tmax to predict the future Tmax. I'll be dropping Tmin and Trange and precip, but later on, I do actually use those in the predictions. In this case, they're not going to be used. So that's what the data looks like there. Here's the test data. The test data goes for I think close to 6 months, from July 26th through December 13th, I think, of 2021. And so we have that data. I actually have the real data in here that was collected 6 months later, but that doesn't matter because this is testing data, and that data is not used in any way. To check that, I actually put the minimum or put the average Tmax in here, ran it, got exactly the same results. So I know for sure it doesn't matter. So here we are setting up the dates that are in the fifth block here, setting up the dates that are in both training and testing, and then setting up some terms that could be useful for the time series analysis: the month, the year, the day of the week, the day of the year. These are terms that could be useful to the time series. And then actually even doing a moving average, and that's on training data. Then we do the same thing on test data. So after that executes, we could see now that we have the month, the year, the day of the week, day of the year, and the moving average. The moving average is 12 days, so it shows up as not a number in the first 4 days, for first 5 days, and then later on you can see the moving average out at the end. So this package is already installed, so I have it commented out, or actually it's not commented out here, but it says it's already installed. And then this is just a plot of the 40 years of data, showing the blue being the Tmax and the orange being the moving average. And then we come down moving here. This is because I ran the dummy. In my previous run, I ran the dummy. Here, if I were to go ahead and rerun this, and we'll take a look at this chart, but you'll see that now I've taken the taken the dummy out, and you'll see the actual data. So this is all running, and we're stuck down here, and you have to hit a return for the rest of the model to compute. So that while that's computing, we'll go back up here and take a look. So here is the actual data that was collected during those 6 months of the late 2021. That's what the data looks like, and this is where the predictions are going to be made from late July through mid-December 2021. So here's where I'm dropping the fields that I don't want to include in the model. So we're dropping Tmin, the range, and precip, and the moving average from the training data and from the test data, just the first 3 fields. So now we have the train And the test data sets, again, here's the headers of those. This is what they look like. So now we just have Tmax and then those parameters that we added that could be beneficial to the time series predictors. And same thing with the test data. So this is a really nice feature here where with pycaret, we're doing the setup of the models. And so you're doing basically training data, test data, your target's Tmax, it's a time series, and the number of folds is going to be 3. In this example, I could run 5, 10, whatever we want, but we're running 3 in this case. I did some sensitivity and it really didn't matter so much for this single example. Whatever the fold was fine. And so these are all the parameters that are set automatically by this package, and they highlight the ones where the thing has been set to true. So remove perfect collinearity and transform the target are true. Now this box 16 is really nice because what it does is it computes all the models that are stored in pycaret, and here they are. Here's a list of them. And so this is the mean absolute error, and then the other error terms that we have, R squared and so on, root mean squared error. And we can see that these are sorted from low to high, so the Huber regressor minimizes the error the most, and then it works its way down through these different models. In this particular case, the way I have it set up, as you'll see, we're going to run extreme gradient boosting down here, XGBoost, which is near the bottom of the list in terms of MAE, but turns out to be one of the best predictors. So these are the model names, and I just put these in as comments so that I could remember what they're called. So here we are now going to actually create a model, a single model to look at and investigate. So we're going to create the model called XGBoost, and then I create an output file name called predictions for XGBoost. We finalize the model. We've got the prediction holdout set here on based on the final selected model. Here are the 3 folds that are run, and here's the MAE that comes out. Here's the model results. When we look then at our predictions, so this is the training data. Then here's the future dates that we've set for the predictions. And so we make the predictions here. Here are the predicted Tmaxes, and then we plot them. And so 40 years of data, and then out here are the predicted values. And then I write the predicted values to a CSV file. In doing this work, when you're doing multiple models, I'm doing 20 plus models, what I've done is I've assembled them into an Excel sheet where we have the future dates. So we have the actual Tmaxes, Tmins, Tranges, and precipes. And then for each one of these columns, N through out here to the rest, all of these are individual models. And so here's the model names over here with the model numbers 1 through 28. And these are the calculated results from pycaret. And then these are some results of sensitivity testing that I was doing to check the extreme gradient boosting with different folds, number of folds. And then finally out here in row 29, this is what happens when you allow Tmin and precip to come in as predictors. And this stuff will be shown in this this article that I'm writing. So what I've done is these are my predictions from the KCB trender, the model 21, and then those are thrown in here in column 21. These are my predictions here in column 21. So this whole data set gets thrown over to Tableau, and then I have a dashboard which allows me to visualize these predictions versus the actual data. So that's pretty much how it's done now. I have different Python workbooks that do more than one model, that do a series of them, or do sensitivity work. But basically, this is the essentially the premise of how this is done. You can run these workbooks and then follow through, set up your own models. I'll put this up for download. You could download this thing, and you have this ability now to set up any model that you want, given your own data set. You could put a simple data set in here and learn how to do these time series predictions using these different kinds of predictors available in Python. So that's it. Thanks for listening. Talk to you next time.